Hello, wonderful people of the internet. Welcome back to another episode of Simuleo. So we've got a lot of little things to talk about today, varying, like just a bunch of things. So let's go ahead and hop right into it and start talking about the first thing, which is actually going to be my most recent YouTube video that I just put out. Let me go ahead and give you guys a link to that. So if I go to Simuleo's channel, and if I go to Leos OS, here it is, Fern of Ferns of Barnsley Ferns. Go ahead and yank this guy, paste it over here. So I did recently put out a YouTube video on the Barnsley Fern visualizations that we were doing yesterday, and in addition there is a chapter on the algorithm archive here on the Barnsley Fern. On top of that, Mamba Dev, I don't know if you guys were there for the conversation, but he also fixed the issue we were having with citations bringing you to the top of the page. Now they appropriately bring you to the bottom of the page, which is great. Also, I think that link was wrong. Let me do this one more time. I missed an H. Okay. And I think that kind of catches everyone up on a little bit of the YouTube and the most recent updates and all this kind of stuff. Now, I actually want to take just a second to ramble a little bit about the most recent YouTube video, and just kind of talk candidly about where this is going and what's going on with it. Right, so a while ago I had this intention of creating a YouTube series that was called like Problem of the Week or something like that. And the truth is, the idea was that, here I'll just write out Problem of the Week, and the idea was that like every week I'd just put out a video on whatever interesting problem we were solving that week. And this seems like a viable plan kind of moving forward, but it's going to be hard to do in the next few weeks, right? Because in 2 weeks I'm going to be leaving Boston, and then on top of that, I'm going to have 2 weeks of quarantine in Tokyo, and then I'm going to be in Okinawa over the summer, then we're moving to Barcelona. It's just a lot of stuff is all happening at the same time, and so it's going to be hard for me to actually start this series, if that is what I wanted to do, in the next few weeks. I might try to put out content more regularly as I can, but it's kind of a bit of an issue. Also, during this last video, I had the kind of two separate tracks. One, I had the writing of the algorithm archive for the Barnsley Fern, and then I had the creation of the YouTube video. I'm kind of doing blue as the algorithm archive, red as YouTube, and pink/purple for Twitch. I mean, you guys know where I stand here, right? Like, for the most part, like the algorithm archive content, I do very much enjoy making. Music's I know why that's the case. Sorry. Yeah. Because yesterday I was doing video editing. And so because I was doing video editing, right. Sorry about that. Thanks for letting me know that. It should be better now. In fact, maybe it's still too loud. Maybe I think that's where I normally put it. Sorry about that. Well, let me reintroduce everything I was saying then, because quite frankly, I'm pretty sure none of you guys could hear me. Sorry about that. So let's go back over here. And let's talk about it. Yeah, I don't know what's been going on with Twitch recently, but we haven't really been getting any viewers on Twitch. So like, the chat's been like super quiet. And so a lot of these problems can kind of go unnoticed for like, longer than they normally would. I don't know exactly what's going on with the Twitch viewership, honestly. It's been quite abysmal as of the past few streams. Could just be because, I don't know, maybe the stream times are weird. I don't know, I couldn't figure it out. Anyway, so I just recently gave you guys links to the most recent YouTube video, and also the algorithm archive chapter and stuff like that. And I kind of wanted to talk just a little bit about YouTube, and kind of what's going on with that and all that kind of stuff. So again, just to reintroduce what I had said, because again, I'm pretty sure you guys couldn't have heard me, because again, the music was too loud. Sorry about that. I had basically at some point in the recent past talked about introducing a new series called Problem of the Week. Now, Problem of the Week was intended just to be like a weekly video series on YouTube where I just kind of talk about whatever interesting problem we're solving that week related to, kind of new research problems and stuff like that. In the creation of the most recent YouTube video, I realized, as always, there are these three tracks. There's YouTube itself, then there was the algorithm archive, and then there's Twitch, right? And it's just every single time I do this, every time I make a new video, I kind of just realize how much I don't like YouTube as a platform. Like, I just don't like doing video editing. I don't like, I'm okay with Twitch. And in terms of video content, I think Twitch is, like, great. Well, okay, let's talk about, like, for education. Let's just draw this out. For, as an educational resource, we'll say EDU, and then we'll say as an entertainment resource, right? So as an educational resource, I think Twitch actually has a lot of potential, right? As an entertaining resource, again, I think Twitch has a lot of potential. YouTube is kind of neither entertaining nor educational to me. And the algorithm archive, I think, is kind of like the number one. This is weird notation, but it's number one in both of these for me. Like, no matter what, for some reason, these perfectly align for me. Whereas I don't find YouTube, like, particularly useful for educational content. So, like, if I'm looking to learn something, I will never go to YouTube. Like, I will go through every single resource I could before going to YouTube, right? Like, it's not that... Like, even if there's a superb lecture, or there's a great video series from, like, a wonderful YouTube content creator, like, for example, 3 Blue 1 Brown or something like that. If I'm trying to learn linear algebra, I'm not going to go to the essence of linear algebra. I'm not even going to go to one of my own videos. What I'm going to do is I'm going to, look up linear algebra and find a textbook, If I'm looking for something in particular, like, I'm going to go to the academic articles for this. Like, I'm never going to click on a YouTube video to learn something. And I was thinking a lot about why that is, and I kind of want to talk about that in a second. But I honestly think that YouTube as an educational platform is just not a good educational platform. On top of that, as an entertaining platform, I just don't watch YouTube videos. Like, I do, but, like, I watch YouTube videos because I make YouTube videos, right? Like, I watch a lot of people who I'm interested in because I'm interested in, like, how their model works, like, why they're successful. Like, for example, Jazza, who is an art content creator that I watch a lot of. I'm very interested in his model for creating content, because he has produced, like, multiple, like, big art box sets that he sells and stuff like that. I'm interested in Linus Tech Tips and MKBHD for the same reason. I'm interested in 3 Blue and Brown and Derek and Destin from Veritasium and Smarter Every Day, because they produce content similar to the content that I produce, right? And so for these reasons, I tend to watch YouTube videos because I'm interested to see how this person is making, a living on YouTube. How are they successful? Why are they successful? All of these types of things. So I tend to find that I watch, like, for example, I'll sometimes watch Mr. Beast as well, because he's got such a weird and interesting model that's just completely different than any other YouTuber I know. So I tend to do a lot of this, but I personally don't go to YouTube for entertainment. Now, Twitch, on the other hand, I feel is, like, really good for educational and entertaining content, because, if you have any questions, you can directly ask the streamer, and, half the time, more than half the time, the streamer will be able to respond and give you direct feedback on your questions. More than that, I just have to be honest here. If you're comparing a lecture on Twitch versus a lecture on any other platform, 100% go for Twitch. Like, because let's say you're doing a live lecture in class, right? I'm not going to ask questions. I am terrified of asking questions in a class. If I'm going to give a lecture, I'm more than happy to give a lecture, but I will not asking questions in a lecture is just another level of just stress that I cannot, like, I just can't fathom. It's so incredibly stressful. But Twitch chat is it's easy, right? Because everyone's pseudo-anonymous, right? So I can say something incredibly stupid, which I definitely am. All my questions are incredibly stupid. And that's totally fine because, again, I'm pseudo-anonymous and it's not me, it's the character that is Leos asking the question. And so for these reasons, I tend to feel that the education in a live stream is way better than the education that you get in a standard lecture. The problem with Twitch, you must be on time. Most of the time, I cannot follow every class. That's true, right? That's also true. And right, I am kind of like picking and choosing the battles that I'm fighting here, right? Like YouTube, for example, if you have a class on YouTube, you can watch it at any time. But the live experience of I see what you mean, right? Because, like, I was just saying YouTube is a bad educational platform because I said it was bad because if I'm looking to find information on something, I will never go to YouTube. But similarly, I won't go to Twitch, right? Like, if I'm looking for a discussion on DMRG, Dense Matrix Renormalization Group, I'm not going to go to a YouTube series. I'm not going to go to a Twitch stream. I'm going to go and find the academic articles about DMRG, right? And I think that I don't know how many people are like this in a similar way, but I honestly feel like this is why the algorithm archive is so important, because like for me, in terms of like educational content, I always go like I will always go to a text-based learning strategy. Like I will always learn via text. That's how I learn better. And also for entertainment, I don't really like watching videos. So I tend to also go to like read books, read academic articles, webcomics. I'm really big into webcomics. I don't know why, but I read way too many of them, and stuff like that. So I've been kind of, I don't know, I've just been really down in terms of the YouTube content, specifically because the past few videos I've put out have honestly just not done very well in terms of viewership. Like basically, I put out a video in 2018, which was on Gaussian elimination. And I've put out basically 10 videos since then, and I realized, like, it's 2021, right? So clearly 10 videos, basically this is what happened. In Gaussian elimination, in 2019, I didn't put out a single video, so no videos. In 2020, and the reason for that was I was writing my thesis and a bunch of other things. There were reasons for that. In 2020, I basically put out 3 videos. In 2021, I put out 4 videos. I put out more videos in the first half of 2021 than I did in the entirety of 2020. I think the numbers might be wrong here. I think actually this might be 5. Yeah, actually, I think I was wrong. I think this is 5, and I think this is 2021, and this is 4. It's still about the same, but the metrics are slightly different. The fact is, my last 10 videos have been like incredibly far apart. It's been a long time since I've been putting out the most recent videos. This last video on Gaussian elimination was not the best video I ever put out. It's not even a good video. Well, okay, it's a good video. I think all my videos are good. But it's not like the best video in my repertoire of videos, right? It's okay. It did okay for the time. It wasn't better than the other videos I'd put out. It wasn't worse than the videos I put out. It was average, right? So far, this Gaussian elimination video is the #1 video of my past 10 videos. In fact, it blows out any video I've put out in these 2 years. Like, it blows them out of the water. Basically, the past 9 videos I've put out have just not done very well. And, you know, on top of all of this that I'm talking about, where I don't really find YouTube as an engaging educational or entertaining platform, it kind of makes it so... It's easy to get burnt out on that kind of stuff. So even though I said I kind of want to start this problem of the week thing, and we can talk about scheduling for problem of the week and all that kind of stuff, I'm just not convinced that continuing on YouTube is the right path for me right now. And I just kind of want to talk about that, you know. I don't know, like I feel like I need to talk about that to someone, you know. I talk to Grant a lot about these types of things, not necessarily about YouTube versus Twitch and all that kind of stuff, but just about, you know, the act of creating content on YouTube. And it gets kind of, you know, is one of those things. Is there a code style guide for the algorithm archive? I think I remember that there was one, but I can't find it right now. Yeah, so if you're looking for a code style guide, we don't have too many right now. So if we go to github.com, well, no, let's just go to GitHub, algorithm archive. Sure, this will bring me there. Algorithm archive, and there should be a Wikipedia here, and then there should be code style guide here. We don't have, so depending on the language, we don't have too many style guides. Like, for example, we have JavaScript, PHP, Scratch. But yeah, so if your language isn't here, don't worry about it. Like, so Go, Java, PHP, Python, Nim, Scratch. If your language isn't there, just kind of have at it. Don't worry so much about it. But even if your language is there, then you do have something to follow. That's all I have to say. Sorry, I didn't do a very good job of describing this. Also, I'm going to do something really quick. This is kind of, I'm so sorry, guys. I know a lot of people really like dark mode, but I can't do it anymore. I'm going to have to go back to light mode. Yeah, that looks so much better. Okay. Go back to GitHub. Okay, perfect. I'm really sorry, guys. I tried to do that kind of dark mode thing for a while now. I know, like, most programmers love dark mode, but I couldn't do it. It's so hard to read. For me in particular. Now, I know, a lot of people, you know, if you guys are struggling to read light mode, again, just carry sunglasses specifically for this stream. In fact, I could, maybe as merchandise, as like the first form of merchandise, I can sell like Simuleo's branded sunglasses for people to stare at my light mode Discord and my light mode GitHub or something like that. Anyway, But this is kind of stuff that's been going through my head recently. I mean, I do think that the algorithm archive content that I put out it's really good. I really enjoy the process of making algorithm archive content, and I really like the final, like the end goal, what it looks like at the end. And I can see like a clear picture of where I want it to be at the end of this year and where I want it to be in the future and stuff like that. I don't have that same vision for YouTube. It's just kind of something I do as something that I use as advertising for the other content. And the only real advantage for doing YouTube is that I could do like a problem of the week type of thing where I have like a vlog style introduction to the type of research that I find interesting and all this kind of stuff, which I think people would enjoy. But it's just, for me in particular, I feel like it's weird for me to make content for a platform that I don't fully appreciate, right? And I think that's where I'm at with YouTube right now. And I've been that way for a long time. Like even before, even when I published my Gaussian elimination video in 2018, I was still very much this way, where I kind of felt like YouTube was fine. It's something that I made, but it wasn't something that I appreciated doing. I don't like video editing. I don't like having my face on camera. Totally fine on Twitch, but like trying to read through a script, I don't understand why, but I would spend like 5 hours doing, like, for my video on it was the most recent one on Computus, the Easter algorithm, the calculation of the date of Easter. I literally spent 5 hours doing like video recording for that video. The video was like 2 minutes, or no, like I think 8 or 9 minutes or something like that. You know, spending, like spending 5 hours for like an 8 minutes of video content is just so, what's the word I'm looking for? Degrading? Denigrating? What's the difference between degrading and denigrating? Denigrating. Harmful and often untrue. So definitely degrading, I think, is what I was looking for. It's hard, like it is really hard. Now, the most recent video I put out notably didn't have my face. And the reason it didn't have my face was because it's just so much easier to make videos with my face not on there. I can just do voice recording and I'm done. Anyway, I guess long story short, I will still be making YouTube videos, but I'm currently looking for ways to lean off of YouTube in the near future. Just because I don't want... I don't feel like it's the right direction to continue moving in. So for this reason, I'm going to try to embrace other projects as well as we move forward. One big project that I had not too long ago was this idea of the subroutine webcomic, and then also have some ideas for games and stuff that we can make, and stuff like this. So basically, my idea moving forward is to kind of diversify more. And the truth is, I'm pretty diversified right now. But the ultimate goal here is that I can basically make the algorithm archive the primary hub of content that I make, and then maybe have like subroutine webcomic for research, for example, and do games for like various algorithms related to game development and stuff like that. Hey, Jump Out, how are you? And so yeah, that's kind of where we're at with that. Again, I'm not really sure where we're gonna go with the YouTube channel and stuff to go from now on, but I just wanted to have like a brief discussion at the start of the stream, just 10-15 minutes. I guess we've actually been talking for 20 minutes, and we can move on to the next topic. Journal, new page before. Okay, next topic. I want to talk a bit about research. Okay, as I've mentioned before, I'm like really keen to just let me try to draw a square. I suck at that. Okay. I'm really keen to do this idea of independent research outside of academia, but I kind of want to just talk about why it's important to do independent research outside of academia instead of inside of academia. So I'm going to just do like two little, academia, and then academia. Well, that's why I'm not there anymore. I can't even spell academia. Is that right? Academia. What the heck? Why can't I spell today? Give me a second. Academia. That's what it is. Perfect. Okay. And then we're also going to do, I don't know, maybe a white line in here. And then we're going to do, on the other side, independent. I guess I'm going to do it in pink. Independent. Okay, so green will be positives and reds will be negative. One big positive of being like an academic researcher instead of an independent researcher is that you can you have a structure already built for you to do all the research that you want. And correspondingly, as an independent researcher, you don't have the structure built. And when I say structure, I mean more than just like the university itself, like the structures that you work in. There's also a lot of like inbuilt structures for, finding grant funding, grants. But also there's a bit of clout, right? If you're a professor at some university, people know your stuff, right? Meanwhile, if you're an independent researcher, quite frankly, if I see someone that's working independent, I'm gonna be honest, I don't trust what they have to say. Like, I know it's kind of an inherent bias in me as a human, but I kind of feel like if you're an independent researcher, like, there's a reason you're independent, and you really have to, like, explain why you're independent versus, working with an academic group, like, or like, for example, maybe an industrial group or something like that. Like, how are you doing research outside of the typical structures that people do research in? I've been using null school and marine traffic to figure stock markets lately. It's worked out for the better being a human at the helm, but I wonder how far an AI will take this theory. Yeah, so there's a lot of good discussions about like for example, stopping algorithms and stuff like that, in terms of like when to sell stocks and stuff like that. And I think actually these could be quite useful for like a similar, I don't know how to put this, like, concept. Like, you could probably use those algorithms to also like train an AI to work better. The truth is, I'm not super sold on this whole like big machine learning trend that everyone's going on. I kind of feel like, I don't know, I guess the physicist in me, like, from a long time ago, I tend to feel like, machine learning is a cool gimmick, it feels, but it doesn't feel like, you don't know what's happening underneath the network. So it kind of feels like I don't want to just train an AI to solve a problem for me. Like, sure, that will solve the problem, but it won't help us understand the problem. And to me, as, I guess, an academic, I tend to want to understand the problem. I don't want to just wave it away with some machine learning method. Which is why when I think of AI and stuff, I'd prefer to use like a stopping algorithm or something like that we can understand in a bit more detail than a machine learning method. Anyway, I'm kind of going off on a tangent here, but you're right in saying that there probably are some AI that can, do this type of, stock trading and stuff like that better than other places. The most I've used is Word2Vec to do pattern matching on transcripts for call compliance. Actually, maybe I should know this. Is this just like, let's go over here, open, control, paste in here. Is a technique for yep, that's what I thought, natural language processing. The Word2Vec algorithm uses neural networks. Yeah, it's quite cool. Like, I do enjoy it. Like, I like it in theory. Like, I really do. It's just that in practice, I just always feel like if I see a physics paper that's like, we solved all of Euler's equation. Well, no, let's say something simple. We solved Schrodinger's equation via machine learning method. Like, if I see solving Schrodinger's equation via deep neural network, I'm probably not going to trust the results of that paper. I'm not saying that it's not impressive that they can do this, right? It's just that I kind of feel like you want to, I don't know, like, we have so many good, robust methods for partial differential equation solving already. It feels weird to me that we're just putting machine learning in it. Like, it feels like nowadays machine learning is all about, like, just finding a new application for it, rather than, like, I don't know. I guess maybe it's just because I'm interested in problems, not so interested in the solution to those problems. So I think that might be the bulk of it. But back to this idea of independent research, right? Like, again, we have to put on the negative here is grant structure, and again, cloud, right? So what I mean here is, if you're an academic, you have a university that you can work with that will help you with teaching. It will help you find people. It will help you find postdocs. It will help you find graduate students, undergraduate students who can help you do your research. You already have an inbuilt structure to run your lab, right? And more than that, a lot of this work is free. And I know that sounds really dumb, but it matters. Undergraduates will work for you because they need the experience of doing research, right? You can use that independent research credit as a class for them. And so it's just kind of like some free research, some free grunt labor that you can use. Now, I'm not saying that's like morally correct. Like, you should not be treating your students as free labor, but you get certain benefits. Certain people will help you with projects because you're an academic, right? And that's not true if you're an independent researcher. You get more grants that you can apply for, and people trust you more if you're an academic. The big disadvantage in academia here is publishing. Now, the publishing industry in academia just sucks right now. Like, it's awful. Like, absolutely 100%. Just awful. Okay, maybe not 100%. They're probably 50% awful. I'm being a bit too pessimistic here. But I mean, for those of you guys who are not academics, a lot of times when people hear that academics are actually not paid to publish, but actually have to pay to publish their papers, oftentimes, like, $3,000. Like, every time you publish a paper, it costs like $2,000 to $3,000 to open access that paper, to make it so other people can read the paper for free. Now, when we're talking about publishing, most people tend to agree, and I'm not saying this is everyone agrees, but most people agree, that having a paper that's funded by public taxpayer money should also be free. So by that I mean, if you have a paper that, the public paid for, that paper should be available to at least the public that paid for it, right? And for the most part, that's not true either. And again, it's because of the way the publishing industry works. Academics have to publish a huge number of papers in order to succeed in academia. And remember, each paper is something fundamentally new that people have never done before, right? And so this act of doing something novel, but also doing something interesting that other people will cite, ends up being this kind of weird, vicious publish or perish cycle where people just... It's like the whole daily vlog thing on YouTube. Like, when you start making daily vlogs, you get really stressed about it, and like eventually you just kind of go over the top. It's the same thing that happened with I don't remember what, Logan Paul, maybe? Whatever. Like, when you start doing daily vlogs, it's hard, right? But on the other hand, yeah, Goldie, scientific publishing industry has to die, but still keeps going. It's really disgusting. Right. On the other hand, I love reading papers. Like, genuinely speaking, academic papers are just my favorite form of literature to read. I love reading papers so much, and I don't want it to die. But also, it sucks. What drawing pad are you using? I'm using a Wacom something tablet. I don't know. I don't know what it is, but it's a basic Wacom tablet. And then this, I'm using Zernal++. So Zernal PP is what I'm using as the like just sketchpad. Hence the archive. Yeah, the archive makes sense. Like, that's the thing. Like, things like the Journal of Open Source Software. I mean, maybe we should just talk about publishing really quick. Let me do journal new page before, and let's just really quickly just touch on publishing, right? So what does it mean to publish? Publish, right? Well, okay, so when you publish, the first thing that you do is you do something novel, something that no one has ever done before. I used to have one and regretted selling it. Honestly, I use the drawing pad as my primary mouse, and I like it. It is a wonderful device just to use your computer with. Sure, it's a bit hard to do specific pixel by pixel manipulation with it, but outside of that, it's actually by using a mouse, I tend to click so much with my finger. I don't know how to show that on screen, but I click so much with my finger that I actually get some sort of weird, honestly, my finger starts to hurt after a while. I can't play video games with a mouse because it just hurts to play video games with a mouse. But, with the tablet, I mean, I can for short bursts, but I can't do anything for that long. But, just for general usage of my computer, scrolling, all this kind of stuff, it's just way better to use a tablet, honestly. Okay, so back to publishing. So the first thing, whenever you publish a paper, it has to be novel. The second thing is it has to be peer-reviewed, right? Now, the important thing here is that what the peer review does is it makes sure that the paper that you're publishing is novel, right? So you do something that no one's done before, and then you have to make sure, other people have to make sure that that thing that you've done is actually something no one's done before. So this is basically all that researchers need, I think, to ensure that the papers that they're putting out are high quality, right? Now, on the publisher side, there's also things that need to be done, right? For example, we need editing, right? And then we also need distribution, right? And I think for the most part, there is a lot that goes into editing, no doubt, a lot that goes into editing. But I think a lot of journals, in particular, pay a lot for distribution. Because, for example, you have journals like Nature or Phys Review X or whatever, just Phys Review letters or whatever, that are high impact publications. If you get published in that paper, or if you get published in that journal, people know that what you did was significantly novel. It was something that a lot of scientists have been looking to do for a very long time, right? And so being having your paper distributed by Nature, having your paper distributed by, Phys Review letters, it comes with it's a good sign of approval, right? And so these two things are basically the only thing that you need. These things in white up here are the only things that you need to keep the scientific industry going. But these are things that the specific publishing industry that we have right now help out with, right? Now, editing, again, you can do editing in an open source way, like the Journal of Open Source Software does this, for example, where you publish your software and then you basically have like a very short paper that's edited by some sort of editor. And that's basically it. It's just a very short paper, but the main thing that you're publishing is the software that you wrote, right? So that's probably a good model that we could use for like, having the editing being done by other people outside of publishers. But the truth is there isn't really a good open access publication group, I would say, that, that is high quality, that people are going to choose over, for example, Nature. Like if you can get published in Nature, your career is basically set, So why would you ever publish anywhere else if you could? If you could publish in Nature, why would you publish anywhere else, type of thing? So on the one hand, I do 100% understand that like the publishing industry sucks because it pressures people to, publish papers that are dubious quality and all this kind of stuff. And I do really think that, we need to find a way to make it open source and open access and all this kind of stuff. But I kind of see how we got here, right? Because like the internet didn't always exist. Like for the past 50 years, 100 years or whatever, since we've been publishing, high quality, papers and stuff, and research that has fundamentally changed the world that we know. These had to be distributed somehow. And so, back in the day, the only way to do it was through some sort of journal that would do that for you. Instead of editing, let's call it curation. That's fine as well. Like, I don't mind. But the point is that, like, this stuff in blue down here is stuff that basically only the current journals can do, and we just need to find a better way to get that done outside of the current publishing scheme. And there are journals that are doing this right now, like, for example, Quantum, I think is doing this very well. Obviously, you can publish everything on the archive, which is just free without the peer review and stuff like this. So there are solutions that people are trying to find, and a lot of researchers in Europe are really pressing hard for open accessing all publications and all this kind of stuff. You can still find your papers all available on Sci-Hub and stuff like this. It's just a sticky web of just unnecessary, it's just hard, is all I'm going to say. So one big advantage to being an independent researcher is that you don't have the same issues with publishing, right? Like you don't have to publish for your career to be successful, right? You could, for example, go 5-10 years without publishing a single paper if you're independent, and that's totally fine. Because, presumably, your actual like financial needs are not set based on your research performance, right? Other big negatives for academia, are teaching, and I'm going to put grants. No, I'm going to put bureaucracy. Bureaucracy. Yep, that's what I'm put down here. And by that I mean, like, as an academic, you tend to find most of your time is just spent in meetings, just talking to people, like just making sure that your research is done appropriately, basically managing your lab and all this kind of stuff. And in addition, you spend a huge amount of time like teaching classes and stuff like that. And if your whole goal is just to do research, these are both negatives, right? Because if you only want to do research, spending time doing teaching, we'll say lab management. Well, actually, we're going to say mentoring. All of this is kind of stuff that you don't need to do. If all you want to do is research, all of this is stuff that detracts from the research, right? Now, I will say, mentoring is fun. Teaching can be fun. The bureaucracy, actually, I didn't mind sitting in any of the meetings. Like, all this kind of stuff, I didn't mind too much, right? Which is why, I don't know, I kind of feel like, though I do have this kind of goal to be an independent researcher, like something that I really want to do, I also kind of feel like maybe it's not the worst idea just to like keep going with academia. Like maybe it's totally fine to get a postdoc and just continue on that path. The reason I left MIT was not because I saw this, deep desire of mine to become an independent researcher, and I just wanted to break the mold and leave academia. That wasn't it. The reason I left was because I had been consistently wanting to do a particular type of research, and I was unable to do that research, both at OIST and again at MIT. And the reason being that I was primarily funded as a physicist, and I just don't like physics. So I was constantly just walking down this path, and I saw my future. I was like, well, if I keep going down this path, I'm going to just eventually be a professor somewhere teaching physics to, a bunch of students who don't care to learn physics when I don't care to teach physics. I just didn't want to do that, So I wanted to at least spend some time writing the algorithm archive, taking a step back, trying the independent path, seeing that it doesn't work, and then going back to academia when that's done, I wanted time to basically resynchronize or change my, CV so that I have something in the area that I want to go in, just out. I wanted to write something in the direction where I wanted to go, so people don't, just assume that I'm just a physicist. They actually see me for more than, they see me for the skills that I want to have, right? So I need to get those skills, and that's kind of where I'm at. On the other hand, I do see there is a path forward with independent research, right? Like science communication, you could probably fund, an entire research lab in the same way that the Linus Media Group funds their channel, right? If you could get, enough money off of YouTube that you could support just one or two people, then you could definitely do novel research. You could just make an entire channel based entirely off of that research, right? And there's something very cool about this idea of just doing independent research and just funding yourself and and everything based off of an online community and all this kind of stuff. And the back and forth I get from Twitch is usually quite nice as well. So I don't know. It's really weird. In France, you can be either 100% researcher or 50-50 researcher and 50 teacher, though the other negative points remain. Right. The other thing, too, is I think you can do that as well in the U.S. because there's places like National Labs, which you also mentioned there, National Research Center, and then obviously there's industry, right? I didn't put industry here because I didn't really choose. I don't really have any intention to going to industry. And the reason I don't have any intention of going to industry is because if I go to industry, my primary role will be software development. And don't get me wrong, it's fine. I like developing software, it's fun, but I don't want that to be my life. And so I'll do it. If I have to, if that's what I need to do, that's fine. It's just I want to explore other options first. Because I just want to explore other options first. I want software development to be a part of my life, but I don't want it to be the primary thing that I'm producing, right? Similar to this discussion I had earlier about how YouTube, I don't mind making YouTube videos, but I don't want that to be the primary thing that I am producing, right? I don't want to be known as a YouTuber. I would like to be known as an independent researcher, right? I don't want to be known as a software developer. I'd like to be known as a researcher, right? This is the type of thing that I've been thinking about a lot in the future. Now, the other thing too is I'm actually 50-50 between research and writing. I just had this whole thing about how I want to do research. I'm always drawn to being an author. I've been wanting to be an author since I was 5-10 years old. I've always wanted to write books. And so maybe I just try that as well. Maybe I just write some books and see if I can publish something. I don't know. There's a lot of just things that I enjoy doing. And I'm just so scattered right now between, the algorithm archive, the YouTube channel, the Twitch stream, potential webcomics, books, everything. I just have so many things that I want to do, and I just need to focus on something, drill in, make that thing successful, and go from there. So anyway, that was a long, long rant. I do apologize for that. The point is that, I don't really know where I'm going, but I do know that I'm getting kind of a bit burnt out with the YouTube thing, and I just don't know where to go with that. So I'm trying to think of other ways in which I can produce content that people would appreciate that might not be YouTube, right? So maybe, for example, I just focus entirely on the algorithm archive this year, and then I just sell the algorithm archive or parts of the algorithm archive at the end of the year. Maybe that's what I do. And then that would help me if I wanted to continue on the academic track. It would it would, mean that I don't have this dependence on YouTube anymore. Now I primarily am known as the author of the algorithm archive, and YouTube is just a side gig, which sounds really nice to me. Honestly, being known as the author of the algorithm archive and using funds from that to, fund my research, like, that would be ideal. Like, if somehow I could do something like that, or even if I publish like fiction and fantasy books or something like this, even if that was just used so that I could also publish papers on the side, like, that would be ideal. Like, the YouTube and Twitch thing is nice. In fact, I do enjoy doing Twitch streams. It's just when you add YouTube on top of it, it's just, I don't know, I get really tired whenever I have to do YouTube content. Like, I just don't have any motivation to do it. Okay, journal, new page before. I want to talk a bit, finally, before, like, going back into the actual, like, before going back into the, like, actual research stuff that we're going to talk about today, I do want to talk just briefly about grants. So here's the thing. As an independent researcher, or rather as a nonprofit organization, which I don't have, but presuming I could create a nonprofit organization, a lot of grants are available to both nonprofits and also to academics. So basically, like, academic institutions. So that means like universities and stuff like that. And I don't know, I've been kind of thinking about opening up a nonprofit that's called Laos Labs, and just, use that to fund the research, just like apply for grants and stuff like that. And so this is also something that I'm looking out for in the near future. Now, I don't really know where to look for grants. The only place I know of is grants.gov. And there's a few good grants available, but also, like, if I'm in Europe, I don't know where to find grants. Like, if I live in Spain, where do I find funding? So I kind of want to just look into it just a little bit today. I know I could have done this, like, outside of stream, but I thought maybe it'd be interesting for people just to see what, like, looking for grants is like. I don't know. I thought maybe people might be into it. So I thought we'd do this for maybe 30 minutes, an hour. And then we hop into the actual research, the fractal compression stuff. And that's kind of my plan. So let me get some more water. Again, if you guys have any comments, questions, concerns, ideas, anything like that, feel free to let me know. I hope it doesn't sound like I'm trolling you, but I left academia 7 years ago, and I am a co-founder of a nonprofit cooperative in Spain. Really? Could you send me a link? I mean, like, I don't think you're trolling me. It's just, that's super coincidence. Like, I'm going to Spain. Potentially, you have a nonprofit, like, I work with grants? No way. It's literally the topic of the stream, and there's only 20 people watching stream. There's no way. But sure, yeah, send me a link or something that I can look at. But also, like, this is exactly what I was going to be looking into. So I don't know, like, that. Like, this is super big coincidence, Also, your name is Golaby, which sounds like gullible. So it does sound like maybe you could be trolling, but I would not have assumed you were trolling if you would have said that. I stopped doing fundamental research, but I'm still publishing. Super cool, honestly. I'm happy to hear that. Yeah, you know what? I really do think this idea of doing both, like, being primarily known as an author is something I've been wanting to do for a long time. And then also, publishing at the same time, like, on the side, sounds great. Like, I mean, I don't want my primary thing. I don't mind my primary thing being research. I like doing research. But if my primary thing was, like, writing books, and that was, like, the number one thing I got funding for, and then the number two thing I got funding for was research, I'd love that. Like, that'd be amazing. Like, in some sense, the YouTube channel is basically a way for me to advertise the other things. So, Mr. Lapis, how are you? Anyway, let's just, I kind of wanted to see what the grant funding is like, for Spanish people, in particular for people, like, individuals living in Spain, and just see what we can do. I just don't know where to look for, European calls for funding and stuff. EU funding, let's do, EU funding and grants for your project. Let's see what we can find. Oh, sorry for the yawn. Okay. Select applicant. No, this isn't exactly what I want. Hey, Amaris, how are you? I hope you're having a great day. Okay. You're the only one I said. I hope you're having a great day too. Everyone else, I'm like, I don't care what you're doing or how you feel, but for some reason, Amaras in particular, I'm like, hey, I hope you're having a great day. Okay, so I'm actually just going to be looking up European like funding agencies and stuff like that, and just see what's available, like what type of stuff is available, to see if I could potentially apply for these types of things. I probably can't because I'm not an EU citizen, in which case I'm wondering if maybe I should be applying for things through grants.gov. And like have a nonprofit in the U.S. I'm not really sure. Not working taste, so that was good. Oh, cool. Yeah, happy to hear that. Let's go to, that was not what I meant to click. I meant to click this one. So usually, I mean, this is the only way I know to apply for grants. Like usually I just go here and I look for computer science, or something like this. And then I see, here's a few grants that are useful, like computer science for all. Usually this is something that, there's something interesting here. It's like this program aims to provide U.S. students with the opportunity to participate in computer science and computational thinking education in their schools at pre-K through 12 levels. In general, like I tend to feel like I'm kind of in the computational thinking camp, and that's where I'm at. Let's take a look. But on topic, I'll send you the grants list in Spain. Oh, dude, that's actually quite nice. Like if you have the grant, like that's amazing, honestly. Maybe because I've been on your streams quite some time. Could be. Okay. What do we have here? So Collectiva T. This is nice. This is actually really cool. Like concept. So it looks like is a nonprofit cooperative formed by knowledge workers that provides all-around services of cultural translation, research, and technology services for collaborative and linguistic work. Yeah, this is cool. Thanks for linking this. Actually, it's really cool. I'm doing a Pomodoro stream. See you in the next break. I'll keep your stream on in the background. See ya. Have a wonderful time. Okay. Thanks for coming in, by the way. Okay. Yeah, this is a different area of academia than I tend to work in, but at the same time, like it's super cool. I'm happy to see that people are doing this type of stuff, you know. So I tend to, like when I'm looking for grants, I tend to just go in here and just look for things. And in general, like I usually try to find ways to fund the algorithm archive through this. So like, for example, the computer science for all, I know about these because I've looked at them before and they're like, you know, you're looking for education for pre-K through 12 levels. I'm like, well, the algorithm archive isn't quite pre-K through 12. But sometimes there's stuff for undergraduate education. So if we do computer science and then undergraduate education, undergraduate, I think we can usually find some grants with both of these together. Computer and Information Science and Engineering Research Initiative. Probably something like this. The NSF Directorate, let me make this a bit bigger. The NSF Directorate for Computer and Information Science and Engineering seeks to award grants intended to support research independence among early career academicians. I've never heard that word before, who specifically lack access to adequate organizational or other resources. It is expected that funds obtained through this program will be used to support untenured faculty or research scientists or equivalent in their first 3 years in a primary academic position after the PhD, but no more than 5 years after the completion of their PhD. So like, for example, I could apply for this. The award ceiling is $175,000, but like, it's something that I could apply for like funding for a year or something like this. Let's see. Faculty at the undergraduate and 2-year institutions may find funds to support undergraduate students and may opt. Yep, right. So it's kind of a way to like kickstart your potential lab and stuff like that would be what that's for. Yeah, I don't know. It's just going through the grants is often like really difficult to do as well, because like you have to kind of know what you're looking for and all this kind of stuff. I think, in fact, what I want to look for, though, is probably computational thinking is probably what I'm looking for, not computer science. Computational thinking. And let's see what we can find. Search. Integrated computational data infrastructure for scientific discovery. Advanced cyber infrastructure coordination ecosystem, computational mathematics. This is a postdoctoral grant. You can see it from the PD. And in some sense, this is kind of the stuff that I'd like to apply for. Yeah, I love the idea of just like applying for these types of grants and just like, you know, getting them as an independent like group, you know, like as a I don't know, maybe I should just apply for these types of things and be like, yo, I'm just gonna apply for it and see where it goes, you know. I mean, basically I'd just be looking for my own funding, unless an exception for the program is granted to facilitate timely notification and the availability of support. The following requirements are in effect: proposals for conferences, proposals to support group travel and meeting outside the U.S. Sure, and the proposals for conferences, right? I don't know, maybe this is stuff we should start like looking for funding for the algorithm archive and stuff like that. I don't know what you guys think about that, like, but maybe it's useful. Can you get it without institutional support? It says unrestricted. Subject to any clarification in text field title additional information. Let's take a look at additional information. Where is that? There's no additional information. It's right here. So it does say unrestricted. But this is something that you'd expect that only like tenured researchers apply for. So I do find it a bit weird that like we're available to apply for it anyway. But let me just see what it says. You know, why not? Apply to PD. Full proposal submitted via Fastlane or research.gov. Proposal submission guidelines apply. I don't know, maybe actually I read through this, and maybe what we do is we just kind of like look at applying for grants and stuff like that. That seems like something that we could do. And I think maybe it's something that, like, for example, like we had a lot of discussion a while ago about doing a distributed transpose algorithm and stuff like that. Hi, I'm a newcomer to the stream. I've been wanting to watch since I saw you in the computational thingy with Julia course. What are we talking about today? We're kind of hopping around a bunch of different topics today about like academia, grant funding, and all of this kind of stuff. And then we're actually going to hop right into, I said hop a lot, I'm not like a rabbit or anything, but we're going to then after that move into discussions about some research that we could do live on stream. Like, for example, we've been hopping, why am I hopping around so much? We have been doing some fractal image compression recently, and so we might actually do some of that later on stream in maybe a few minutes. Right now I just kind of want to see what grant funding is available for projects like this, to see if, you know, like we had this discussion about potentially doing independent research, and I'd just like to see if maybe we could apply for grants and see if this would help us out, you know. So maybe actually this stream is going to be a lot of just like looking at grants, seeing how we could apply for them and stuff like that. I'm not really sure. But yeah, it's been a long time since I did the Julia computational course. Actually, I just realized it's May 13th. So it's been 5 months, since I helped with that course. And I think the course turned out really well. Like, we were obviously crunched for time, and there were a lot of like, it was a weird dynamic. The bot should say simulates as a bunny then. I don't know why I say we need to hop around so much. It's just my default, like, we're going to move to this topic. I'm going to say we're going to hop onto this topic. I don't know why. But yeah, with the computational thinking in Julia course, I don't know, like, I feel like it was a weird dynamic between myself and all the other lecturers and stuff. I always felt like I didn't really fit in. I did my best, but, you know, maybe I didn't do as well as I could have. But I was constantly trying to, like, you know, make the best content I could, given the constraints, right? And I think we did okay. I think that course went very well last term. I think this term is probably even better, without me and Grant. But, you know, it is what it is. So the synopsis for this one says, it supports mathematical research in areas where computation plays a central and essential role, emphasizing analysis, development, and implementation of theoretically justified and efficient algorithms. The combination of these elements resulting in innovative computational methods is a hallmark of the program. Proposals ranging from single investigator to interdisciplinary team projects that not only create and analyze new computational mathematical techniques, but also implement them in a model study and solve important application problems are strongly encouraged, as is providing opportunities for rigorous mathematical training of junior computational mathematicians through research involvement. I think maybe we could actually apply for some of these. I don't know. I'm kind of excited to try. Let's see. So the proposal window is from November to December 1st, 2021. And when do you hear back? Maybe we do. So a revised version of the NSF proposal and awards policies. No, I want to see. When do you get information about this? I mean, if the proposal window is from November 16th to December 1st, then my question is, what has been funded? This should be pretty good to look at. Collaborative research, data-driven. Actually, you know what? This might be a good opportunity just to talk about different research projects that we could do, and where they could fit into the overall scheme of like where people would fund this type of stuff, right? This is quite good. I think this is something to look into. So the first thing that we're kind of working on right now is obviously the fractal image compression stuff. Fractal image compression, right? So in particular, what we'd have to do is phrase this in a way that we can provide a robust new algorithm to increase the efficiency, increase efficiency of known methods, right? Of known methods is something that we could promise, right? Then another thing that we could promise here is actually, what else would this be useful for, right? Like, I mean, under what situation do people actually want to do fractal image compression in 2021, right? Like, it was thrown away in the 1970s. So we need some sort of novel implementation of fractal image compression that, like, like for some reason, why would you do this over something else? So we probably want some sort of application of this. So we want an application where it beats out JPEG. I guess that's fine. That's not really ideal though, right? Like we want something where fractal image compression, like it is able to compress something that other things can't do. Like it can do something that other things can't. I think I'm gonna go. I'm starting to yawn my way too hard. Sorry, CMRS, have a wonderful evening. And yeah, hopefully see you around later. So what kind of application would we be looking for here? Again, one that beats JPEG would be ideal, but I think we want to use image compression to do something beyond image compression, right? Like for example, we could maybe use fractal image compression to, I don't know. Yeah, maybe this isn't ideal. Okay, I mean, obviously we have the creation of different filters, which is fine. We have the addition of the fractal flame method. Right, okay, so the ideal thing, so what we want to do here, if all goes well, we do a direct analytical representation of an n-dimensional space. That's what we're looking for, an analytical representation of n-dimensional space. The holy grail of fractal image compression is taking any image and turning it into a direct set of mathematical equations, and that is exactly what we want. So that's the holy grail. This is what we're shooting for with this particular project. Okay, another project that people might want to fund would be the distributed transpose. Right, so for those guys who might not have been around for the distributed transpose stuff, this was a long time ago where we were talking about basically how to appropriately do a transpose on highly parallel systems, right? Highly parallel and distributed systems. So think GPUs connected to multiple other GPUs in a high-performance computer or something like this. This is particularly useful for basically anything that uses an FFT, which means basically the entire class of spectral and pseudospectral slash pseudospectral methods. Pseudo starts with a P. Pseudo? Spectral, right? So basically anything that uses an FFT could use this very well. Another ideal like method here is potentially the I mean basically anything that has to move data around quickly. So this is really useful for high performance computing and things in this area. ... I mean that's useful as well. Journal new page after this time. Ooh, first time for everything, right? So another big topic that I thought about doing before would be some sort of octree based representation, octree spectral method. This is basically a way to compress the data. Here's where things could get interesting. Okay, hear me out. So octree spectral resolution here. So basically the idea would be that if you have some sort of n-dimensional grid, right? And you have some sort of like weird glob on the center of this grid that you're trying to represent in some sort of spectral way, well, you have areas of high density and areas of low density, right? But basically the only thing you really have to worry about for the spectral representation is the areas where you're changing from high density to low density. So this region in here is what you have to care about. So because of that, you kind of know the location that you specifically have to pay close attention to, right? So if you're trying to like store as much data as you possibly can, well, what you might do is you might basically treat this as one giant region and treat all of this as one giant region, and then kind of split this little bit in here up into little blocks, right? And so the idea with the octree spectral representation or whatever is that we still do the FFTs and everything like you normally would, and you can do specifically because if you're splitting the grid into quadrants, it's easy to split that back out into octants or whatever that you need to do the FFT with, right? So you're not changing the underlying grid so much. But basically being able to represent the grid as an octree and basically split it up into areas of high and low density, and basically perform the FFT over areas that only have low density would allow you to basically store. I'm not saying this appropriately, but basically what I'm trying to do is find a way to store the data such that we don't have to store this region, and we don't have to store any of this region out here, and we only have to store the areas where high and low density are changing, like where we're changing between high and low density. So this is another idea that I had for some sort of research moving forward. And then there was also maybe something else here. Like, I think the area of basically data storage, for basically large systems of PDE solves. So again, like you think of like fluid simulations, superfluid simulations, these types of things. I think this is relatively unexplored in some ways, like because the methods to solve the problem domain are complicated, right? This means that you don't want to make the data itself complicated. But I think maybe, I mean, they're not relatively unexplored, but compared to other areas, like, could use some exploration. So maybe there are better ways to store, like, the underlying grid and stuff like that. And so some of this is also stuff that I've been thinking about in the future. All of this really does heavily, like, fall into the area of computational science. Computational science. And so, in some sense, I'm looking for basically anything that falls into the area of computational science for these research ideas. Now, the other thing too is that everything to do with the algorithm archive falls into the region of computational thinking. So basically, I can look for any grant between, like, for computational science and computational thinking. I'm going to be honest, these are not in computer science. And I know this is kind of weird, but I do not think I can apply for computer science. I don't think I can apply for computer science grants. Let's see, I don't want to derail the stream, but do you want to consider a grant field that is more application? Yeah, we could. I mean, all of these have, like, really good applications, right? Like this one here, for example, these two here, actually, both of these, are basically anything like from climate science, to, basically any PDE solve. So climate science, quantum, simulations, it's just a huge area. Like basically anything in computational physics fits in under these, right? And same with this guy up here with the distributed transpose. The truth is, I'm gonna be 100% honest here. I don't want to run simulations. I really don't. If I have to run a physics simulation, I'm gonna tear my hair out. Like, I don't want to have to do, like, if I run a simulation and the end results of the simulation, like, if my part of the project is running the simulation, checking to see if the results are physically accurate, I'm not going to like that. But that's where you work in collaboration with other people, right? So I could basically call on people and say, hey, would you mind working with me on this project? And if they're, like, other people are more than happy to do that part of the project, right? I just don't like that part. And so, you know, the application side might come from another collaborator or something like that. Or maybe even people watching the stream, they're like, oh, I'd love to do that. And it's like, cool, great. You know, I don't know. Anyway, I guess my point is that I've got a lot of these projects that I do want to kind of work on. And the question is, how do you fund that? Hey, Vexitos, how are you? We were just talking about a bunch of different things, like different research projects that we could look into as independent researchers and things that we could work on as academics and stuff like that. So I want to give you an example. We're doing computational linguistics in the co-op, and we apply for grants that are very sector specific. Right. Let me get some water. But computational linguistics is like huge. There's plenty of people doing that kind of stuff, right? So I'm sure there's a lot of grants for that. Also, I missed a bunch of follows. I'm so sorry. I'm doing really bad with this today. I got no follows. Mr. Lapis, Gulliby, Wolf Spammy, and also Pleon98. Thank you guys so much for following. I don't know what I was doing. I just wasn't looking at notifications at all today. I just suck at that. For some reason, I've been doing an awful job doing notifications. For example, we partnered with a fact-checking nonprofit to apply for this. Let's take a look. Okay. Oh, this looks nice. A fact-checking development grant. The International Fact-Checking Network is dedicated to furthering innovation by establishing best practices in the field. Thanks to support from YouTube via the Google News Initiative, the IFCN has $1 million in grant funding. Oh, that's quite nice. Available for established fact-checking units that are pursuing projects around video production, tool development, audience building, and new format testing. Fact-checking units can apply for $50,000 each. So how do you apply for what is a fact-checking unit? Like, what does that mean? Grants will be distributed based on the proposals, including but not limited to activities below. Oh my gosh, I can't speak. Using videos as a tool to disseminate accurate information. Publishing fact-check videos for new and traditional media outlets. Developing tools to support fact-checking workflows. Audience building for sustainability. Let's see, leveraging existing or building new programs for crowdfunding, membership and fundraising efforts, new formats and mediums to expand and the reach of fact-checking. They find fake news? Right. Right, okay, so my question then would be the following, right? Like, if you're funded to be a fact-checker, what does that mean? Like, it sounds to me like this comes in two different camps. One are people that are just producing good, like, research and explaining how and why you would do the fact-checking. But the other are creating, like, is this like the development of novel fact-checking algorithms or something? I guess that's my question. Where's the novelty in this? What is a new thing that you're doing if you get this grant that other people have not gotten, or have not done? I think that's my question. Sorry if that's naive. I don't really know the answer to it. Let's see, what do we have here? We basically want to apply speech recognition to their flux. Right, that makes sense. New computation methods for understanding the functional role in DNA variants. Every time I think about DNA, I go back to the good old-fashioned. I recently came across a language that basically is like a full Turing-complete language in like DNA transcription. It's pretty interesting. Collaborative research in computational neuroscience. Let's see. Investigator-initiated research. Computational approaches to curation at scale for biomedical researches. My issue here is that I'm a bit worried because I know I'm going to be moving to Spain. I'm a bit worried that I'm not able to apply for a lot of these grants anymore because I'm no longer in the U.S., right? And I feel like that's definitely going to be the case. I feel like it should be the case. I don't know, maybe it's not, but it just feels like that makes sense, right? If I don't live in the U.S., I can't apply for U.S. grants, even if I am a U.S. citizen. But if I have a company in the U.S., that's just where my my significant other is going, so we're gonna be there together. Hopefully, we'll see. It's been a rough couple of years, honestly. I've been in a distance relationship since December 2019, and because of COVID, we haven't been able to see each other. Well, no, we've been in a distance relationship since September of 2019. But because of COVID, we haven't seen each other since December of 2019. So it's been like a year and a half since we've seen each other. And so, hopefully that will be fixed next month. About this time, I should be flying to Japan, and we should be able to see each other again. And then hopefully in the fall, we should be hopefully living together in Spain, but we'll see. By the way, Mama Dev, thank you so much for the stuff earlier. Just wanted to say that I really did appreciate all of the work in getting the citations to work. So I called it out earlier today, but essentially Mamba Dev did a lot of work to make it so when we click a link, we actually go down to the bottom of the page where the citation is for that link, which was not the case for some reason yesterday. I don't exactly know why it wasn't working, honestly, but there was a lot of like back-end work that needed to be done to fix that, that I just don't know how to do. So like I'm actually super grateful for that. Okay, I'm gonna take just a 1 minute break, guys, just to grab a little bit more water. So give me just a minute and I will be back, and then we can hop into some more maybe non-grant related discussions, like maybe discussions about computational like fractal image compression and stuff like that again, and see where we need to go with that, and then kind of keep continuing along that path. So I'll be right back. Okay, I'm back. Give me just 1 minute. Just one last link for European grants. You should take a look at the Horizon 2020. I'll leave it for you to check later. It's quite extensive. Yeah, let me take a look at that as well, since I don't know anything about getting European grants. I actually don't know, like, am I allowed to apply for European grants? Like, I have a visa to live in Spain. Well, presumably, I will get a visa to live in Spain. I don't have one yet. But, that would mean that I could apply for European grants, but I couldn't apply for US grants. I don't know. By the way, Extra Gee, thank you so much for following. Really appreciate it. Horizon Europe. Close here. Horizon Europe is EU's key funding program for research and innovation with a budget of 95.5 billion. Tackles climate change, helps to achieve the UN Sustainable Development Goals, and boosts the EU's competitiveness and growth. Okay, growth. I can't speak. I'm so sorry. The program facilitates collaboration and strengthens the impact of research and innovation in developing, supporting, and implementing EU's policies while tackling global challenges. It supports creating a better dispersing of excellent knowledge and technologies. Okay, so I think what I'm kind of reading, hear me out, what I think I'm kind of understanding here is that maybe, okay, hear me out, just hear me out here, right? Maybe what I could do to solve my whole YouTube dilemma is just kind of cut YouTube out entirely. Hear me out. Just don't make YouTube videos anymore, okay? Focus entirely on the algorithm archive and Twitch, and then apply for grants. Like, why not just do that? You know? Like, the YouTube channel is not making me any money, really. The algorithm archive is making... none of these are making me any money, right? I mean, in the grand scheme of things. So it's kind of one of those situations where, like, you know, I'm looking for sustainable growth. I'm looking for something that I can like, I'm looking for some way to fund my future development, right? And having, like, books or something that I sell is one way to do that. Having grants that I get funded by, also something I could do. I mean, the YouTube channel is really good advertising, though. I mean, again, it is advertising. Maybe I just leave it going because it's really good advertising. Yeah. Oh, it's just if I leave it going for advertising's sake, then I'm gonna have to do a lot of, you know, like, I have to make videos to make it good for advertising, you know? Like, I kind of feel like maybe what I should do is, instead of working on my own channel, I partner with other people's channels, plural. And so, like, if they need content from me, like if they need someone to look up algorithms or work with something, it's like, I'm your guy, I can help with that. And then in response, they also just, like, plug the algorithm archive or something like that. I don't know. I get really, like, existential about YouTube every time I make a video, so I get kind of, we'll see where it goes. Okay, let's just kind of hop into the next topic. And to end this conversation here, I think what I'm going to say is, one, there is funding available. There is funding, right? It's just a matter of applying for it and then actually getting the funding. And here's the thing. The reason academia is so nice here is that you have a job independent of grants, right? This money is you know, something that people call soft money. Which basically just means that I think I've heard this word. Anyway, the point is, it is a type of funding that you are not guaranteed to get next year, right? You only have it for as long as you have grants and stuff available, right? So what you want to do is get enough soft money that you can turn it into hard money, right? Money that you can definitely guarantee that you will be getting next month and next year and the year after that, right? And so even though there is funding available, I think having some way in order to get money every month so that I can make sure that I'm like, you know, sustainably growing and stuff like that is obviously still something that needs to happen. And right now, the only way I can see of doing that is through YouTube, right? Like, it's the only way of seeing how to do that right now. I mean, we could do Twitch, we could do the algorithm archive, but the algorithm archive just isn't earning enough via Patreon to really grow in that way, or like really to like set my career off on. Again, there is a way, like, so okay, let's talk about where that hard money comes from. You know, one way is through YouTube, right? And then, you know, also, in addition, other online content, which we'd say is the algorithm archive, and also Twitch. But another thing that we could do here are, like, books, for example, which would be like the algorithm archive, like a version that we sell of the algorithm archive. But also, like, back a while ago, I was writing, like, various, like, you know, fantasy novels and stuff, which I know probably won't sell, but I don't know. Part of me really still wants to write that stuff. I still really like that, like, the stuff that I used to write. Like, I went back through it and I was like, this is actually really good, and stuff like that. So basically, the places where I can see hard money coming from are primarily YouTube, but also other online content like the algorithm archive and Twitch, maybe like Patreon and GitHub sponsors, but then sellable objects like books, and stuff like that. The other thing would be potentially merchandise. But I mean, the thing about merchandise is that, like, merchandise has to be tied to an online platform to be successful. So anyway, sorry, lots of rambling today. Let's go ahead and hop right into the next topic, journal new page before, which is going to be fractal image compression. Fractal image compression. Okay. Yeah, there's actually, I don't know where we want to go with this. So there's a lot of really interesting avenues to explore here, and I don't actually know the appropriate direction, like what the best direction is to go. So what I'm going to do now is I'm going to list out all of the possible directions that we can go in, and then we're going to try to figure out what makes the most sense, like what direction actually makes the most sense, right? And again, I'm doing this live on stream because the hope was that we could get a few people to kind of like talk about it and see what they think is the best idea. Because, just a single person doing their own thing isn't really useful. You need kind of a group of people that are all kind of on board and moving together in the same direction. Okay, so first of all, what is fractal image compression? Let's say you take some image. Here's the image in here. The idea is that you can create a set of equations. One second. Equations. I'm just going to say EQNS, equations. That basically turn that image into an attractor for an iterated function system. So again, pulling back from links that we just made, we just made a chapter on the algorithm archive for the Barnsley Fern. And I also just put out a YouTube video. The idea with an iterated function system is that you have a set of equations that create some sort of n-dimensional image, right? And so the idea is that if you have this image, you can then basically create a set of equations that will regenerate this image, right? So that if you take a lower quality version of the image, we'll say LQ for this guy, LQ, and you basically use that as the initial set of points, you read that into the set of equations, you're going to get back the image, right? So fractal image compression basically works by creating an analytical form that roughly approximates the image, and then reading in an approximation to the image to recreate the image itself, if that makes sense. So you get a factor of compression of like a quarter or whatever, like you compress by a factor of 4 or something. It works pretty well. It's obviously lossy. Let's see, lossy. But so is JPEG, right? And so the thing is that a lot of people were comparing fractal image compression back in the day to JPEG, right? And a lot of people really like JPEG. It's definitely lossy. Like, I'm sorry, like, there's nothing you can do about it. But yeah, so a lot of people back in the 1990s, right when JPEG was coming out, it was becoming like really common and popular, were comparing fractal image compression to JPEG, and basically they found that the two of them have roughly comparable. Actually, let's just go down here and let's create a new thing. So JPEG versus fractal image compression, which I'm just going to say is this FIC. Okay, so JPEG have roughly comparable, like I don't know how to notate this, so I'm going to remove that line that I drew down here, and we're going to say their compression rate, oh jeez, for Pete's sake, 1 second, I can't today. Their compression rates are roughly equivalent, so JPEG and fractal image compression have roughly the same compression rate. What JPEG does way better than fractal image compression is compression speed, so encoding speed. It is, and also in a sense decoding speed as well. But I'm going to put decoding over here. But basically my point is that the encoding speed for JPEG is just way faster than fractal image compression. We're talking about like hours faster than fractal image compression. Like JPEG can compress an image. If JPEG compresses an image in 0.5 seconds, fractal image compression would take 5 hours to do the same image. And this is again back in the 1990s. And so, that's actually what we're talking about right now, Chucko, Bomb Guy, Gary. But yeah, so it took like, literally 5 hours. And again, we're talking about 1990s technology, right? So we're talking about like really old school, like CPUs that really couldn't do very much. Obviously it wasn't properly parallelized. There were a lot of just issues with these implementations, but you have to imagine that if hardware advanced, and a lot of people started developing for JPEG, right? What used to take 0.5 seconds probably takes like microseconds now to do. And this guy down here probably could be compressed down to 0.5 seconds, right? Or something, right? But I haven't seen really any papers to prove this. Like, how fast can you actually make a fractal image compression algorithm? That's one very interesting question that I don't think is solved right now with current technology, right? So let's go ahead and just talk about like things that we could do with this information. So one big question I have is, actually, I'm going to do this in text mode. So one big question is, how fast can fractal image compression be on modern hardware? Okay, so that's one big question I have. But I also have another question. Can fractal image compression work better with different, we're going to say, I'm going to call them fractal flames, and I'll explain what those are. Okay, so like I said before, the idea of basically fractal image compression is that we take an image and we represent it as a set of equations, right? Which is great, you know, but the question is, how do you come up with that set of equations? And usually the way it's done is by basically creating like a bunch of different affine transformations, and kind of just like working with these affine transformations here and there, until eventually you have some that seem to recreate the image, right? And so in some ways, by having like a bunch of different available affine transformations to work with, you can recreate the image in a relatively good way. But this idea of having multiple affine transformations, multiple different, fractals put together, in order to recreate the image, is also the idea of the fractal flame method, which is basically the idea of like combining, for example, the Sierpinski triangle with the Barnsley fern, for example. And by putting these guys together, you get a new fractal that's like the Sierpinski fern or something. And the question is, if you, instead of creating one set of affine transformations to recreate the image, use multiple sets of affine transformations to recreate the image, does this make the compression space, does it make it easier or harder to do that compression, right? So that's one question that I have that I don't really have an answer to either. Another question that I have is, let's see, how do I put this? How do we know? Okay, here's another question that I have. How do we, and I think this is actually related to one. So let's move this guy down a bit. And so 1A over here, 1A is going to be the question of how do we parallelize this GPU? Okay, that's the next question that I have. People would really like JPEG if DCT cubed was used more often. That's actually another thing, right? So we talked recently about how to speed up spectral methods, right? And DCT is like just a real part of a Fourier transform in principle. So, we talked about the distributed transpose and how this could be used to speed up basically any type of spectral method on a distributed set of hardware. Is there reason to do like a large... No, there's no reason you'd be using JPEG with a supercomputer. Never mind. I thought maybe there would be a reason to use a distributed transpose with JPEG because of the DCT, specifically because of high dimensional DCTs, which is where like a distributed transpose method would work very well. But you're right that this is actually not... we're kind of like digging too deep into something, like trying to find an application for a project. It's probably not worth it. Okay, but this question of how do we parallelize this on the GPU is another really good question because of the way iterated function systems work. So journal new page before. We talked about iterated function systems before, but for those of you guys who may not have been here for a while, and I kind of just introduced it without really introducing it here on stream as well, let's just talk about it. So the way this works is we have essentially a set of functions. F1 is going to be equal to, maybe we have 3 points here, A, B, C. So F1 would be equal to whatever your point location is plus A over 2. F2 is going to be equal to whatever the point location is plus B over 2. And F3 is going to be equal to the point plus C over 2, right? So the idea here is that if we start at any random point, let's say this point over here, and we let it choose one of these functions at random to move according to, let's say it moves halfway towards A, it will eventually, by picking these functions again and again and again, redraw the Sierpinski triangle. So we'll make it move halfway towards B and then halfway towards C. I don't really know, but the point is eventually it will land on the Sierpinski triangle. which for those of you guys who don't know is just, oh gosh, I can't draw, is just a triangle of triangles. Just pretend I can draw, because apparently I can't. But the point is that after a successive iteration, let's say maybe 10,000 iterations, we have redrawn the triangle, right? We've redrawn the attractor. Now, this is really cool because it means that you can, generate the shape of your system after like 10,000 iterations. But if you're doing something in parallel, like let's say on the GPU, doing 10,000 iterations of a thing is not really good because you're doing it in parallel and each core is pretty crappy. So the question is, if we're appropriately parallelizing this and we're finding a way to basically take this inherently iterative process and put it on the GPU, which we have ways of doing. We've come up with ways of doing. The question I have is, how efficient is this? Is this actually useful? Is it fast? It will be faster than the CPU method, but is it accurate is the next question. So my question here, oh, sorry, I went to the wrong desktop. So my question here is not only how do we parallelize this on the GPU, but the follow-up question here is how do we tell how efficient a parallel method is? Okay, and this is where we come up to another interesting question. So let me move this down again because we're just consistently finding more interesting questions that we have to dig into. So we're going to move this down here, and now I'm going to create a new little text thing here, which is going to be 1AA. Okay, so the question with this one is not, so how do we tell how efficient a parallel method is? I forgot an L here, there. Okay, so 1AA is going to be, okay, so how do we tell if we are attracted to the Sierpinski triangle? Okay, misspelled triangle, every time. Triangle. Perfect, okay, so the question here is, let's say you have a point, like the point that we drew up here. How do you know how far away that point is from the Sierpinski triangle, right? That is actually a surprisingly difficult question, one that we tried to tackle on stream and didn't really have any good solutions to. But we found a paper that was published maybe 2 months ago that did actually solve the problem. It was just the problem was incredibly difficult to solve. And so the question of finding a distance metric of a set of points from an attractor, which again is another set of points, is quite difficult to do because we don't really know what the attractor looks like. Without drawing that set of points in the end, right? So the question is, how do you find a distance metric if, like, all you have is a set of points that are kind of sort of on the attractor because you generated them also with the chaos game that could also be lossy? It's just a weird question to have, right? So this question here is actually quite interesting because this is going to mean that we go into a bunch of rigorous mathematics that I really don't know the answer to. Okay, so now we're going to move on to question number 2. Can fractal image compression work better than with different fractal flames? I guess this will be actually a third topic entirely, but, oh shoot, I just lost it. What was that other topic that I was going to talk about? So we talk about the distance metric from the individual point. I guess the next question is, so how fast can a fractal image compression be on modern hardware? How do we parallelize this on the GPU? How do we tell how efficient a parallel method is? How do we tell if we're attracted to the Sierpinski triangle? I guess the next thing we want is, can fractal image compression work better on different fractal flames? Oh, I completely forgot where I was going with that. I'm so sorry. Let me get a little bit more water. Oh man, my nose is stuffed up as well. Okay. Right. So all this stuff with fractal image compression. My next, yes, I know. The big holy grail question is 3. Can we represent an image as only analytical equations? That's the big question. Right. So if we talked about fractal image compression before, we basically said that, we have the image represented as a set of equations, right? And then by reading in a low quality image to the set of equations, we can recreate the high quality image. But there could exist a world there could exist a world where we could take any n-dimensional plane, any n-dimensional surface, or not plane or surface, any n-dimensional just thing, volume, whatever, and we could turn that into a set of equations that we could then recreate via a chaos game. In which case, we wouldn't have to keep any images or any like data at all. We store it as explicitly equations, and if we're able to do that, that's actually really cool. It would really change like what we think of, or how we think about image compression as a whole. So this here, that is the holy grail. Let me highlight this actually. This here is the holy grail. This is a dumb way to highlight things, isn't it? This is the holy grail of what we're looking for. Can we? Gosh darn it! This is the stupidest way to highlight something. Because it's black in the background, so the highlighter is not really showing anything. Anyway, the point is, can't we represent an image as only analytical equations? That's the overall end goal that we're looking for. The answer right now is obviously no, but maybe in the future there is a way to do it. I don't know. But it would definitely be a really interesting, data compression question to solve at some point in the future. So that's kind of like where we're going with this. And so I guess my question to you guys, the stream audience, is, where do we actually want to go with this? We talked a few days ago, about how to do the parallelization. Talking about GPUs and all this kind of stuff. We also talked about how to tell if you're attracted to the Sierpinski triangle. We talked about fractal flame methods. We've talked about, basically we've covered all these three things, and we need to cover all of these before we can tackle number 3, because we need a good implementation of fractal image compression. So there's a number of things that we could do. The first is we could really just drill down into this one, right? We could go into the rigorous mathematics, and we could try to figure out that paper that we were looking at not too long ago, and just try to figure out how we understand the distance metric. How do we understand how far away we are from any given attractor, right? That could be something that we do, and it could be quite interesting. People could get really into that. I don't know. When I was talking to Grant about this, I basically told him that one of the questions that I had asked, and one of the questions that I was trying to solve, had a research paper that was like 2 months old. When we looked into that, or when I said that, he was like, "Oh, you should definitely make a video on that, because that means that it's something that no one's ever done before." And I was like, I don't know, because it's something that people have done before now, right? It's a research paper. People did it, so therefore it's not novel anymore, right? Do you want sharing the paper? I need to find the paper one more time. Let me do that really quick. So we go here, CD into projects, research. Oh, maybe let me go to downloads. lsstar.pdf. I have a paper on the cuttlefish algorithm. Okay. There's some stuff here that might be, there it is. It is on the convergence rate of the chaos game. On the convergence rate of the chaos game. Let me make sure I didn't have anything like incriminating on here for my PDF record. Nothing really that bad. Yeah, I think it's all fine, hopefully. Oh, it's probably fine. Okay, but this is the paper. So I'll open it up here on stream, and I'll explain why this might not be the best direction to go in. This is go here, Zernal PP on the convergence rate of chaos games. Okay, move this over here. So the reason this might actually be quite challenging to continue working on is that this paper is really dense. It's let's see, that's page 2. It is, what is this? About 30 pages of just like rigorous mathematical definitions that it's just hard. I don't understand all of it, if I'm being totally frank. And I've completely forgotten most of the notation. It's just a lot of like rigorous mathematics that I don't know, so I'd be learning a lot on the fly. What I should probably do is just read the paper on my own, maybe not on stream, but like it'd be like a week of me just trying to figure out this paper, essentially. and that would be basically my life for a week, which is fine. I don't mind. Like, I think it's actually kind of fine to do. I enjoy that type of stuff. And then the question is, where does that fit into everything else? Well, this gives us a distance metric from any given attractor, which is quite nice. And the advantage there is that then we could use that distance metric when we do the parallelization here to see how bad the parallelization is. Like, is this actually going to work for, like, you know, can we actually use this appropriately? For number 3, this feels a little like Laplace or Fourier transform. Intuition says any image can be encoded purely in equations as long as you're happy to have enough equations. I guess in some sense you're right. I mean, that is actually exactly what the Laplace and Fourier transform do, right? Yeah, I'll give you that. Yeah, I think you're completely right. I guess specifically what I was looking for is, yeah, specifically, okay, let's not say analytical equations. Let's say specifically with, as only an iterative function system. Okay, and in this way, I kind of clarify here. I'm talking about, like, specifically a set of transforms or something like that, as essentially affine transforms on top of a group of points. But in some sense, I think you just explained why, like, for example, JPEG using DCT is like just way better than fractal image compression and stuff like that. Just because it's kind of doing the same thing, it just does it better, you know? Okay. So if the truth is, though, we could skip 1AA entirely. Like, we don't have to do that. We don't need a distance metric from a single point to the Sierpinski triangle, or from a distribution of points to the Sierpinski triangle. And the reason we don't need it is because, quite frankly, the research project, getting to step 3, you know, implementing fractal image compression for the first time, so doing the implementation of fractal image compression with fractal flames would already be novel in its own right. Doing the parallelization here, again, that's also quite novel, something people haven't done appropriately. So doing fractal image compression on the GPU with fractal flames is already novel enough for a paper. The question is, can we go a step further? And I think the idea here would be that all of this, so we're going to say 1A, and also 2 would be enough for paper 1, and then we'd be looking at another paper for 3, right? That's kind of what we're looking for. Now, my question is, can we just ignore this second A? And the answer is probably, right? Because I don't like that. I feel like we should do 1AA. I feel like we should. Because if we can find a distance metric from any point to the attractor, we can then find... Yeah, we want that, because then this also gives us a compression ratio, right? This gives us a compression ratio. This gives us a compression ratio from our image, right? Because that's what we need, right? Because if we're trying to compress an image, yeah, we need to know how far off we are from that image in the end. So I think this is actually way more necessary than I was giving it credit for. Having some sort of way to tell, you know, how far off are we from an attractor is actually very relevant when your attractor is very complicated. Yep. Okay. You guys have convinced me. Okay. Cool. So let's take a look at the paper. Okay. Oh, geez. So now the question is, what do we actually have to learn from this paper? Like, what are we trying to figure out? I'm really tired, and I don't know why. It might be because I haven't been working out recently, because I took the shot on Tuesday. So I just, the second vaccine I got on Tuesday. So I've been quite just out of it recently. So I think what we want to do, okay. How do we want to parse this up? So let's go ahead and do, let's move down here. So this looks to me like we have actually 3 different papers. Okay, so the first paper is going to be the extension, oh gosh, for Pete's sake, extension of the paper referenced in 1, whatever this paper is over here, to fractal image compression. And by this, I mean, what I want to do is I want to take their distance metric that they've figured out in hard, rigorous math, and basically put that onto the computer, I know this sounds really like lame the way I'm saying it, but basically take that, put it into some sort of computer code so that we can basically find the distance metric from any arbitrary attractor, right? So that's what we want, any arbitrary attractor. And I think that in and of itself is already novel. 2 is implementation. Implementation of fractal image compression on GPU, right? And then with the fractal flame, with fractal flames. I'll say F flames. Okay, and then finally number 3, which is an ambiguous one, which quite frankly would be the holy grail, but I'm sure we're not going to get there, is full representation, of image, full representation of image with iterated function systems. Again, if we could get there, you know, our career is set, like totally fine, never going to have questions again, like we're perfect. Like I could just apply as a professor somewhere, I'd be fine. No way we're going to get there, right? Ideally, if we could just do 1 or 2, like that's kind of where I'm at right now. So where does that leave stream and everything? I think what I'm going to do then, because actually I'm quite into this right now. I think I'm going to just take a step back, try to get through the paper, and basically try to figure out how we extend it to fractal image compression. So that's what we're going to do. I'm going to spare the paper reading from you guys on stream, so I will do that off stream, and I'm going to come back with what I understood from the paper, and we're going to try to tackle the bits that I didn't understand on stream tomorrow, probably starting at 4:00 p.m. Eastern. So that's where we're wrapping up today. I realized it was kind of a weird stream. We didn't really do too much, but we have a plan for the future moving forward, and I'm actually really happy with that. We talked a lot about where we're at in terms of YouTube and Twitch and everything, so it was a good stream, no matter the case. I think that's it for now, so I'm going to go ahead and leave. I'm not going to read anybody today just because I don't feel like talking to anybody. I'm so sorry. But I will talk to you later. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys next time for the next episode of Simuleos, which will be tomorrow at 4:00 p.m. And yeah, we're just going to start doing it. Unapologetic research streams, trying to do problem of the week, this type of stuff. So our problem of this week is just going to be, can we extend... It might be a problem of the month, but can we extend this paper onto fractal image compression? Can we do it for any arbitrary attractor? So I guess tomorrow, before doing any of that, I guess the first thing we need to do is implement fractal image compression. That's probably what we need to do. Anyway, I'll try to get this order down. I'll write everything down, kind of get my thoughts situated and go from there. Thanks again, guys, for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I'll see you guys around next time for the next episode of Simuleos, where we get some code down and really start hammering this out. Thanks again, guys, and I'll see you next time. Bye, guys.